Alright, so hopefully you've already tried this pattern and you are watching to see if you did it right, if you got the correct answers to the questions. If you had some trouble with it, then let's see how we are doing these and maybe where you went wrong. So first things first, things that we always talk about in class are to take the pattern and organize it into a T-chart first. So we always have our term number here, term value. So the first term is 8, the second term is 13, the third one is 18, the fourth one is 23. So we have 1, 2, 3, 4 terms given to us. And those 4 numbers are 8, 13, 18, 23. So I know I didn't ask you this, but it's a good idea to always write what the pattern rule is in words, because it gives us some good information. So this pattern starts at 8. We always say what number the pattern starts with, and then how does it change. Well, to get from 8 to 13, we're adding 5. To get from 13 to 18, also adding 5. And same thing here. So this pattern is a linear growing pattern. It starts at 8 and increases by adding 5 each time. And that's a very important piece of information. The add 5 each time is very important. Okay, so what it wanted us to do first is extend this table and just extend the pattern up to 10 numbers. So, oops. Let's go with our 5th, 6th, 7th, 8th, 9th, 10th numbers in the pattern. If I just keep adding by 5s, this one's easy because every other number ends in a 3 or an 8. So I'm going to be 28, 33, 38, 43, 48, 53. So the 10th term number or term value is 53. Easy enough to extend the table and do that if we're just going up to 10. But we want to get up to the 75th term number, and I don't want a table that has 75th entries. So I'm going to come up with an expression. What I remember from class, or what I hope you remember from class, is when we start our expression, we always look at what value is the pattern going up by each time. Does it go up by the same amount each time? If it does, that's great for us because we know it's a linear growing pattern. And this goes up by 5 each time, which means there's multiples of 5 in the pattern. So because of that, we always start our expression with 5n. So the 5 comes from the fact that it adds 5 each time, and the n is just our term number that tells us what we're going to multiply the 5 by. So for the first term number, it's the first 5. The second term number, there would be 2 5s in there because from where I started, it's 10 more. I doubt this is the correct expression fully, because if it was, the pattern would go 5, 10, 15, 20, 25. So I'm pretty sure I have to add something on to the end here, or subtract. To figure that out, we practice checking our first term. So my first term is an 8, so hopefully I'll calculate 8. And when I use this expression, n is the term number. So for the first one, I'm going to use n as 1. 5 times 1, that gives me 5. Unfortunately, that is not the first term number. So I'm off by 3, it looks like. So what I want to think to myself is, well, how can I change this expression so that if I did calculate with n is 1, I would get 8. Right now I got 5, so I think to get to 8, I need to add 3. So I'm going to do add 3 on my expression as well, because that'll give me 5 plus 3 is 8. Hopefully Now that I've edited my expression, it'll calculate all the rest of the numbers for me. So I'm going to check the second number. So I'm going to use n is 2. Hopefully it'll get me 13 when I calculate it. So 5n, so 5 times 2 this time. I'm going to use n is 2 because I'm checking the second term. And now I'm going to add 3 because I've changed my expression to put an add 3 in there, and hopefully that will get us what we want. 5 times 2 is 10, plus 3 is 13. Bingo. 13 is the correct term number for the second one. I'm going to check the third one again. Hopefully that will work out for us. So the third one, n, will be 3. So 5 times 3. And I still have plus 3 in here because that's part of my expression now. 5 times 3 is 15, plus 3 more is 18. Sweet. Now that I've checked the first 3 of the pattern, I know I'm right. Here is my expression. And this will work for every single term number that I want. So for me to calculate, there's the second one I want. Any term value that I want, I'm simply going to do 5n, 5 times the term number, plus 3. And so what it asked us to do is figure out the 75th term value. Well, what that means is if I was to keep going in my chart, what would the 75th number be? What would this be? Well, okay. N is 75 this time. 5 times 75 plus 3. Well, 5 times 7, that's 350. 5 times 5 is 25, so that should be 375 plus 3, and that should be 378. So what that means is the 75th number in my pattern is 378. I also notice it ends in an 8, so that's good because every other number here ends in an 8. And every odd term number ends in an 8. 1, 3, 5, 7, 9. So 75 should end in an 8 as well, so that's good. It's a good thing for me to check, to double check. So here we go. Another example of how I can piece together an expression that will calculate any number in a pattern that I want for a linear growing pattern that increases by the same amount each time.